Good afternoon, good evening, and good morning from wherever you are. I'm Dr. Yao Zhang from University of Southampton, and I would like to welcome our audience and speakers to the 12th HUE UK and Ireland Women Engineering Ambassador Program Early Career Talk. And I would like to invite our HUE UK and Ireland Vice Chair, Dr. Nagham Saeed, to open this webinar talk.
Hi, everyone. I will open the talk and I welcome everyone. And I would like to say Happy International Women's Day. And I will pass it to Cobra. Thank you very much.
Hello, everyone. First, I would like to say Happy International Women's Day. And I am Kubra Duran. I'm a PhD student in the School of Computing, Engineering and Built Environment at Edinburgh Napier University. And I also volunteer for the IEEE United Kingdom and Ireland Women in Engineering Ambassador Group. And today we have 4 speakers.
Yeah. And I would like to mention that presentation recording will be broadcast on HUE section Region 8 YouTube. And there will be 1 question for audience after each presentation. So provide your email in the evaluation form, which is at the end of the slides, if you want to receive your e-certificate, which should be received within 4 working days. And before we start, here are some housekeeping notes. And you will notice that you are muted and you can't use your camera. And if you do have questions that occur to you during the talk and you don't want to lose track of, then please do type them into the Q&A chat box and we can address those at the end. And to target the questions to the right speaker, please write with the question the speaker's name or her talk order from 1, 2, 3, or 4, and we will try to answer the questions at the end of the full presentations. And now I will hand over to Kubra for the agenda of this event. Thank you.
Yes, today we will host the 4 speakers, Dr. Nour Ghadban, Dr. Muge Erel-Ozcevik, Dr. Xiaolan Liu, and Dr. Waqas Nawaz. And it's from each presentations, we will take the questions and address them to the speakers. If you have any questions, please put them into the Q&A box.
Let's welcome the first speaker.
Okay, the first speaker is the Dr. Nour Ghadban. Please, when you are ready, share your screen. The scene is yours right now, Nour.
Hello, everyone. Does the screen show?
Yes, yes, we can see your screen. Yes, you can start.
Okay. I'm Dr. Nour Ghadban. I'm a research fellow at University of Glasgow. I'm working on AI and feature extraction and speech recognition systems. My research explored the development of adaptive autonomous systems that can interact with unknown environments. Especially, I'm working to assist hard of hearing individuals in recognition speaking words and sentences, even in noise environments or wearing masks. Before joining the University of Glasgow, I worked as a lecturer at Turin University in Syria. During my journey, I have a Laureate in Oscar for Women in Science Award for my work in improving audio and visual features for Arabic speakers. And I also have Women in Science Chair Award for my project that I will lead in the University of Glasgow for gender bases in healthcare AI and find ways to ensure that AI supported treatment equality. My primary focus on promoting and encouraging women in science. Really, we want to speak about AI, robotics, feature extraction.
No, I don't think your slides are moving.
Sorry.
We are still seeing the first slide.
Okay, sorry. Yeah. When we want to speak about AI, robotics, and feature extraction 5G, we have to answer 5 questions about how is artificial intelligence transforming the capacity of robotics? What roles does feature extraction play in the advancement of machine learning within robotics? In what ways does 5G technology enhance communication for these robotics systems? How do emerging technology like edge computing, IoT, and advanced sensor contribute to the evaluation of robotics, and what potential of this technology integrates hold for the future robotics in various applications. AI enhances the autonomy and intelligence of robotic systems, enabling them to perform complex tasks with greater accuracy and adaptability. AI can optimize robotic workforce leading to increased efficiency. And robots with AI can adapt to changing conditions and perform a wide range of tasks. AI can also enhance the accuracy of robotic operations, reducing error. And about feature extraction, that means we have to achieve the best features that can increase efficiency and the accuracy. So when we use AI with feature extraction, we can make our decisions are better and accurate by distilling the vast amount of raw data in more manageable number, and AI systems then can process and analyze this data more softly and efficiently. The selection of these features to influence the accuracy for these models by eliminating noise and irrelevant data. And feature extraction also helps optimize computational resource reduction, both time and energy, compensating for training model. We can use lots of feature selection methods like filter methods, wrapped methods, embedded methods, and dimensional reduction and hybrid methods. And even all of this has the applications that we can apply in these features. For example, for filter methods, we can use technical select feature based on their statistical properties. We can use, for example, person correction convention that compete correlation between each feature and the target. We can use CHI square test that we can assess the efficiency between features and targets. We can use wrapped methods for evaluate performance of feature subsets using ML algorithms. We can use forward selection methods to add one feature at a time, selecting the most improving. And we can use REF for rank and remove least important features. And we can use also hybrid methods for filter and rapid methods to know what is the best feature that we can use as in hybrid methods. The introduction of 5G works provides high speed, low latency, and communication essential for real-time robotic operations such as autonomous vehicles and telemedicine. When we integrate that feature extraction with 5G and robotics, we can bring lots of technology and we can integrate together. Like when we want to bring the processing power closer to data sources, reduction latency, and allowing for faster decision making on robotics, and we can apply it in IoT to connect reports to a wider network of devices and sensors to advance and collaborate and data exchange. And we can add more sensors to equip robots with the ability to detect and interrupt wide range of environments simulation for feedback to visual causes. And we can apply all this technology in many sectors, such as manufacturing, healthcare, and urban management. That we did in University of Glasgow. We applied all the concepts that I say in adding radar to audiovisual speech recognition systems to help hard of hearing individuals to recognize the spoken words or systems in challenging conditions. So we add radar to audiovisual speech recognition system, and we take benefits from radar that can give us features to increase the robustness and increase the accuracy for these systems. And we can also say that radar can work very accuracy with across various environmental conditions that ensure that our performance is better, and that which will help hearing impairments or disabilities to recognize the words by adding these features to audio and visual features to speech recognition systems. But when we use radar into audiovisual speech recognitions, that means that we have computational complexity and resource demands. So this is why we apply feature extraction and selection and address algorithms on our program. That means the accuracy is better, as we say, and we can say that the inference time is better, that this time is the real time responsible for deep learning model is so essential. So when we add a feature extraction, we have more accuracy, and we have this time is so better for our application. In conclusion, with continuous advancement, we are approaching a future where intelligent robotic systems are an everyday reality, enhancing productivity and innovation across various industries. Thank you so much.
Okay, thank you, Nour, for your nice presentation. I am checking the Q&A box right now. So from the attendances, if you have any questions, please put them into here, and I can directly ask them to Nour, or the speaker can address your question by using this box. So the first question, the Nour, is how does integrating 5G technology enhance AI-driven feature extraction in robotics, and what are the main implications for next generation applications?
Yeah, the most important thing that we have to know about accuracy and about the real-time that response in robotics. So when we use feature extraction and we use adding sensors to our application, that means we can involve two more important things in application with 5G and robotics. And about the application that we can use it, we can use in IoT, in healthcare, in manufacturing, all of them.
Okay, okay, thank you. And the second question is what challenges do researchers face when integrating emerging technologies like 5G into AI-driven robotics, and how are these being addressed?
I think the most important things now is how we can make it secure, because some application have the security is better than another things that we have to apply for and think about it. So I think we have to know about the protocol and maybe apply about some protocol, the security that will we apply IoT on any 5G and robotics and AI.
Okay, okay, thank you so much for your presentation and for your talk, Nour. And okay, then we can switch to our second speaker. Muge, if you are ready, you can share your screen and start presenting.
Okay. Now I'm sharing my...
Yes, we can say it.
click on this part. Now see. Yeah, you can see.
Yes. Yes, it is in the presentation mode right now.
Okay, thank you. Hello, everyone, again. Let's start with my talk named as Blockchain Secure Software-Defined Networks. First of all, I'm Assistant Professor Dr. Muge Erel-Ozcevik from Software Engineering Department of Manisa Celal University from Turkey. I'm also head of Software-Defined Everything Research Group in my university. And let's look some biography information. My PhD, MS, and BS degrees was from Computer Engineering Department of Istanbul Technical University, and I would like to thank to my supervisor from back to this progress. I have received several awards with my PhD. I have graduated with 17 international journals, and thanks to that, I have honored with third rank from TÜBA and in 2022. And my PhD thesis has also been awarded by IEEE Turkey section and also Istanbul Technical University. I have many conference paper, best paper awards, and also I'm serving as a TPC co-chairs, TPCs, and also reviewing in several international conferences and also journals. And my current studies are software-defined networks, blockchain, digital twin, Internet of Things, and etc. And today I will go into detail my just published journal named as Sustainable Fixed Wireless Access with Blockchain Secure Software-Defined Network in Pervasive and Mobile Computing. You can also go into detail if you have many theoretical details. And let's start with the introduction. According to Ericsson reports, we have the global mobile data traffic exceed 80 exabyte per month, and 5G subscribers are expected to reach 4.4 billion by 2027, and most of them are in eMBB, enhanced mobile broadband contents, and it requires under 4 millisecond and delay requirement. This is caused by augmented and virtual reality-based smart city applications, wire-based offices, and also online educations. And fixed wireless access is expected to offer broadband to 300 million connections projected in 2028, and it exceeds to 90 gigabit per month for a smartphone. But it cannot handle these huge requirements and also different requirements of contents, because in 5G we have different contents such as enhanced mobile broadband, ultra reliable low latency, and massive machine type communications. And for example, eMBB needs huge bandwidth requirement with moderate latency, URLC needs zero latency, and MMTC needs extra capacity requirement. And with fixed wireless access, these are served by monthly guaranteed service instead of quality of service. Therefore, I'm focusing on monthly guaranteed service in order to handle these requirements. And the main problem is configuring some equipments and using same equipment in the topology. And thanks to software-defined network, we can decouple data and control plane and also dynamically configure the physical equipments without any touch to physical topology. And due to persistent economic reason in a pandemic, there is a partial recovery instead of full recovery with limited resources. Moreover, the indispensable goal of 5G is minimizing the risk of physical deployment. And I believe that SDN, thanks to dynamic configuration, will overcome the physical risk of deployment. But there is also another challenge in SDN. We have open flow switches in data plane, which periodically controlled by control plane. They are DEM devices, and the control plane configures periodically these dummy devices. How we can configure such switches? Because in the cloud network, we are familiar to using software as a service, but in the edge parts, the open flow switches, current open flow switches, are only used by infrastructure as a service. That means network administrators are not allowed to configure software parts of open flow switches, because we have hardware and software parts of open flow switches. Therefore, in order to handle huge amount of data traffic, we can also use soft open flow tables in each equipment, but this should be done by dynamic configuration. And the multi-tenant, there is no also there is a limitation about to use such same physical equipment between multi-tenants. This is the main problem. Therefore, we believe that this can be only handled by infrastructure as a service and also software as a service by using at the same time and by using dynamic configuration. There is also security challenge for dynamic network slicing in software-defined network. This can be categorized as network privacy, standardization, contention between providers, and computational work in OpenFlow switch. By handling both of them, the research question is, how can the service providers keep their own network sustainable by using infrastructure in a secure, cost-efficient, and confirming the standard in a fair way? This is believed to handle it by sustainable fixed wireless access. It has OpenFlow switches. It uses OpenFlow switches as a service by using hardware and software parts both, and the service providers can hire same physical components in order to configure their requirements. It reduces operation and capex by decoupling data and control planes. And SDN controllers is also having global V1 topology, and it can handle periodic end-to-end configuration on each virtual slice. We are seeing the proposed model actually in the left-hand side. We have infrastructure provider and also other virtual slices. For example, for MOAT, URLC, and EMBB, it has own SDN service provider controllers, and we can use same physical OpenFlow switch thanks to the dynamic configuration and also virtual slices. Each service provider can request to hire OpenFlow switch, and these trading are stored in a blockchain. Because we do not need any centralized authority in order to save such trading. For example, the transaction can be stored as a service provider one virtually configures OpenFlow switch one in a such off-coin fee, and this data can be stored in OpenFlow blockchain in a distributed way. And I have two main metrics in order to handle this dynamic configuration and also enhance the sustainability of the network. Sustainability is calculated by 1/, cost of megabit per second and also waiting time according to load of switch. And the cost of megabit per second are calculated as the number of current switches in the topology and the cost of per switch. And in order to handle guaranteed service, which is defined as fee, we should handle new fixed wireless access, which are capable of OpenFlow communication capability. And we have therefore extra expenditures in the conventional case, but in the proposed case, we have hiring principle. We can increase the software-based OpenFlow tables, and thanks to dynamic configuration, we can use secure implementation. Same physical OpenFlow switch can be configured by different SDN service providers of multi-tenants. And here off-coin fee is pretty low than the newly having new expenditures for new OpenFlow switches. And then this is the example of blockchain. In here, I have a proof of stake mechanism in order to handle low cost, low computational overhead on the topology, but the different blockchain mechanism can be also used. And for example, the transaction data can be handled as service provider 2 virtually configures OpenFlow switch 1 according to such fee. And after the transaction requests are taken, SDN controller service providers and also OpenFlow switch signs are taken, and these data are stored in our distributed blockchain in each OpenFlow switch database. In OpenFlow switches, we have configuration scheduler in order to take such hiring requests to use OpenFlow as a service. We have smart contract manager in order to authorize these SDN service providers. And we have security policy database to store these blockchains. And afterwards, we have content scheduler. because each content has different configuration requirements. URLC, EMBB, and IoT has different priorities. For example, URLC can be handled in the hardware-based table in order to forward quicker than the others, but EMBB and MOAT can be handled in the software-based table in a sustainable way, actually. We have also different slides for service provider 1, service provider 2, and service provider 3, and they have configuration capability on each slices, and we have also another public slice in order to generate data. And this is the main communication diagram. First, the service provider creates the transaction request, OpenFlow switch and service provider signs the smart contract, and these smart contracts are stored according to proof of stake consensus mechanism, and the blockchain is committed into different OpenFlow switches, and these are stored in OpenFlow switch database. According to results, for EMBB and URLC content, if we can look the cost per user, while comparing the conventional one, EMBB content is decreased nearly $40 per user, but URLC content decrease, we have nearly $50 dollar gain. According to cost per megabit per second, we have 0.3 gain in EMBB, and we have 0.0 gain in the URLC content, according to cost mechanism by using OpenFlow switch as a service. While looking at the guaranteed service, we can handle much more guaranteed service than the conventional one, thanks to this strategy. If we increase the raw user intensity in a switch, after 0.9, the conventional one cannot handle much more traffic because the drop rates are started after this ratio, but we can handle this traffic up to 1.2 by using extra software-based tables. After the 1.2, we can also decreasing the capacity. We need extra OpenFlow switches in order to handle increased incoming requests. And proof of stake mechanism can be also implemented in our topology because it mines a block in a millisecond level, and each block can have 1,000 transactions. Therefore, this is also implementable in our topology, but the other paradigms, proof of evaluation, proof of evaluation-based, and also stake-based mechanism can be also used as a feature work. And as you can see, we are comparing the proposed and the conventional one according to sustainability, where the user intensity is increased in the x-axis, and the red one can only be handle incoming requests, but the other cannot. Thanks to software and hardware-based tables and the dynamic configuration doing by STM, we can use OpenFlow as a service, and we can handle sustain topology thanks to this paradigm. And as a result, we have obtained 40% and also 53% for URLC and EMBB content on cost per user. And thanks to OpenFlow-based blockchain, the service provider offers more service sustainable network to end users to meet higher user intensity while comparing the conventional one. And as a feature work, the proposed sustainable fixed price access motivates us to connecting services by pricing service at the transaction level instead of service level. This will pay for transaction as a service on pricing strategies. As a result, the more service will provide, the more cost efficiency for us. Thank you for listening, and I can take the questions if you want.
Okay, thank you very much for your informative talk, Dr. Muge. I am checking the Q&A box right now, and the first question is, what are the main benefits of the proposed method to service providers and end users?
According to, thanks for this question, by decreasing the prices, operational and capital expenditure, according to service provider, the cost efficiency will be performed. And according to end user perspective, by decreasing again capital and operational expenditure thanks to this sustained open flow switch as a service strategy, the cost per megabit per second and also cost per user is also can be decreased. There is actually pay-as-you-go strategy in here, and thanks to transaction as a service and also open flow as a service strategy, we can use such techniques which minimize all costs for both service provider side and also end user side.
Okay, thank you. And the second question is, what are the future impacts of this research?
According to, we are considering now infrastructure as a service and software as a service techniques in physical topology, and this will bring switch as a service, and also we can handle pay-as-you-go strategy thanks to these blockchain-based security mechanism. We have no centralized authority in order to have such trading and also store this mechanism, and thanks to our future work, transaction as a service, we can handle much more cost efficiency in our topology discovery actually.
Okay, okay, thank you so much, Dr. Muge.
Thank you.
Okay, if you have any more questions, please put them into the Q&A box so that the speaker can respond to your question by using this box again. And actually, for the audience, before switching to our third speaker, I can briefly share my screen. So that is the reminder of our feedback form. Please do not forget to fill the survey using this link in here. So actually, I will also put this link into the chat in a minute. So we can send you the e-certificate, and this will help us to deliver better webinars every time. And once again, please provide your full name and email addresses, so which are essentially required to prepare your e-certificates. And thank you. And now we can switch to our third speaker, Dr. Xiaolan Liu. When you are ready, you can share your screen and start. Yes, the scene is yours.
Okay, hi everyone. Thank you for inviting me for this talk. So, sorry. So my name is Xiaolan Liu. I'm working in Institute for Digital Technologies as a lecturer in Loughborough University. And today my topic is gonna be the distributed learning in wireless networks. So first, I would like to introduce myself, some background. I'm currently a lecturer in Loughborough University, and also I'm a visiting research fellow in King's College London. And I was graduating in Primary University for my PhD, and I did 1 year research associate in King's College London as well. And currently I'm a member of IEEE Women in Engineering, and also the Communication Society. Now, I'm also an editor of IEEE Internet of Things and IEEE Wireless Communication Letters. And here today, my topic will go through the following 5 content. The first, I'll introduce the motivation of the distributed learning in wireless networks. And I will introduce a few current classic distributed learning algorithms, including the federated learning and the split learning. And then I will introduce the hybrid learning techniques for the heterogeneous networks. And then I will go through the energy efficient user scheduling. So first, the motivation of distributed learning in wireless networks, because currently when we have our many different devices, we are using like our smartphones, wearables, and also the autonomous vehicles, and a lot of IoT devices that are appearing in the wireless networks, and they are all geographically distributed. So there are a lot of data sets that are generated and it's naturally distributed. So, and the other thing is there are a lot of advanced applications supported by these IoT devices and smartphones, like object tracking, recommendation system. So they all rely on the machine learning algorithms and to extract the features from this distributed data set. So here requires a privacy protection. And also there are some devices, they are improved, the hardware, they are improved to support the machine learning capabilities. So in this case, we can find a distributed learning, find a distributed way to process the data, and especially in the wireless networks. So in the wireless networks, we know that our mobile phones and many IoT devices, they support the wireless connections. And when they have a lot of data sets generated, if we want to process those data sets, and if we want to transmit them to a central server to process, it will consume a large time delay, and also it will need a lot of power consumption. And also, if we transmit the data to the central server, it will reveal the user's privacy. And also, since we're talking about these devices like our new iPhone, they can support the machine learning model training, and also the ARM company, they provide some light devices, they can support the light GPU. And in this case, since most of the wireless devices, they can be computationally powerful, and they have CPU and powerful GPU even to support the machine learning model training. So we're considering we can leave the data at the user side, and we can let the user to process its data by itself, and we only share the machine learning model parameters. In this case, we can protect the user's privacy. So first, I'll introduce this federated learning. It has been talked a lot in recent few years. So federated learning, it has the idea that each user, we will have a global model, and each user will receive this machine learning model from the server, and then they will train the machine learning model with their own data set locally. And then after this trained, they will share the model parameters with the central server. So the central server will then perform this model aggregation. The basic technique of model aggregation is to do the Fed average. And after that, you would broadcast the new model parameters back to the users. So while doing this for many rounds, a global model will be trained. And the other distributed learning is the split learning. So split learning has the idea of they split the whole neural network, because we know from the LangNet, AlexNet to ResNet, the neural network has hundreds of layers, so it will be more complicated. So in this case, the split learning looks the idea of cut the neural network into two different parts. So the small part will be put at the user side, and the complicated layers will be put at the server side. So in this case, the user will have less layers, so they will need less computation capabilities to support the local training. And since the federated learning and split learning, they have their own advantages and also the disadvantages. So we were looking for if we can combine both of them together to support the heterogeneous wireless networks. So first, let's say the heterogeneous wireless networks. The heterogeneity generally, it comes from the three different sides. The first is the communication heterogeneity. So this case is because of the different users, they will have different communication conditions. The second one is the computation heterogeneity. This means that different devices like IoT devices and the mobile phones, they will have different computation capabilities. The last one is the statistical or data heterogeneity. So this one means that the data generated at each device, the overall distribution is non-ideal or imbalanced. So to deal with all of these heterogeneous networks, the hybrid learning techniques we propose that can be useful. So the idea is that we can, if we just let some of the users to use the split learning, only train a part of the neural network, and some other users to train the full machine learning model, and then we do the similar thing at the server side to perform the model aggregation, and then in this case we can let some of the users who have less computation capability to train less neural network layers, and some have higher computation capability to train the full model. So we have some performance, the simulation results we got. For the learning accuracy, the hybrid split learning split and federated learning architecture, it can have higher accuracy than the other benchmarks. Here, the split learning and centralized learning, they have similar learning mechanism. So they have the highest learning accuracy. And if we consider the training time and the communication overhead, we can see that the training time, the hybrid learning technique, it can converge faster and then the split learning, and it has less communication overhead than the federated learning and also the split learning. And when we were talking about, we let some of the users to choose split learning and some of them to choose the federated learning. And how do we actually schedule them to do that? So we came up with this energy efficient user scheduling scheme. So here the user scheduling scheme, the idea is that we have to choose some of the users when they have good channel conditions, but also at the same time, we have to choose the proper learning method, like split learning or federated learning for each user. So this problem, compared to the general classic user scheduling scheme, it becomes a joint user selection and learning method selection problem. And we formulate the problem to minimize the energy consumption, and then at the same time to select the users and also select the proper learning method for each user. And then this problem, we can formulate them as a multi-choice knapsack user scheduling problem. So this multi-choice knapsack problem, it means that for the central server to select the users, we not only select the users, for each user, it can have the one learning method is federated learning, another one is split learning method. So it has two layers of the scheduling problem, and this can be perfectly solved by this multi-choice knapsack problem. And then we can get some results by performing our method in a different data distribution. So we did on the IID data, non-IID data, and also the imbalanced data set. So from here, the figure B, we can see that in the imbalanced data set, the more users, they will choose the split learning method. This is because the split learning method and the communication overhead, it depends on the data set of the user owns. So here, if it's the imbalanced data and some of the users, they have less data set size than the others, so the split learning method will be selected for these users, and for the other users, they will use the federated learning method. And then we'll also compare the energy consumption comparison, and we can see that our method, it has the less energy consumption and it has the similar test accuracy compared to the other two methods. Okay, so that's all of my presentation of this distributed learning in wireless networks. And here comes the conclusion. So the main purpose of this work is to solve the computation, communication, and the data heterogeneity in the wireless networks when we want to implement the federated learning frameworks. And then we propose this hybrid split and federated learning architecture. And also by introducing this split learning and federated learning method selection, the new joint user scheduling scheme has been studied. And yeah, that's all my presentation. Thank you.
Okay, thank you, Dr. Xiaolan, for your nice presentation. And we have two questions in the Q&A box for you. The first one is asking, how can federated learning be useful in wireless networks?
Yes, so I think federated learning has its, the main purpose is to protect the user's privacy, because we have quite a lot of users, they can generate the data, and by using this kind of technique, we don't need the users to share their raw data. They only need to share their features and model parameters. So in that case, their privacy will be protected. And also in wireless networks, we also care a lot about the bandwidth. So in this case, if we transmit less data, that will be more efficient in the future networks. Yes.
Okay, thank you. And the second one is, can the edge device support the training of learning models?
And currently, there are still researching on this, but from the what I have seen is that some of the iPhones, our mobile phones, they can train a small machine learning model, and also the ARM company, they have developed like a very light GPU, and they can put on the IoT device to train a small machine learning model as well. And also here, the split learning, it will be a very popular choice, I think, because it can let the user side to train a smaller version of the machine learning model. So in that case, it can also be the a very good option for the future.
Okay, thank you so much, Xiaolan. And from the attendances, if you have more questions, please put them into the Q&A box so that the speaker can address them. And okay, and we can switch to our fourth speaker, the Mohammed Waqas Nawaz. Yes, Mohammed, whenever you are ready. Yes, you can start.
Yes, can you hear me?
Yes, we can hear you.
That's nice. I'm sure you can see my screen as well.
Yes, we can see.
Okay, sorry. Hi, so thank you. I just would like to express my gratitude to the organizer for their hard work in making this event possible. And thank you for joining this online talk, and definitely wish you a happy Women's Day. Your presence is greatly appreciated. Thank you, and let's get started. So my topic is about from data to wisdoms, transformative path of robotics with 5G. Let me introduce myself. I am honored to be here with you today and would like to take a moment to introduce myself. My educational journey, I have a PSc honors from Kingston University and MSc from UWS, and now I'm a fully funded PhD student from the Engineering and Physical Research Science Councils. I have experience as an associate data scientist and research assistants, and recently with the graduate teaching assistants. And my affiliations are with EPSRC, UK Research and Innovation Council, Microsoft, because I'm a registered data scientist. I also have worked with the European Space Agency on an internship at the 6 months. I have collaborated with AI drivers who are creating autonomous driving companies. So my passion lies in advancing communication adaptability in distributed environments, like actively contributing to the knowledge aggregation in autonomous vehicles. Sorry. Okay, so before I start, I would like to highlight the knowledge aggregations, applications, and 5G benefits. So, in terms of autonomous systems, that involves the exchange of information, insights, and experience related to the development, operation, and improvement of autonomous systems. The knowledge aggregation plays a crucial roles in advancing technology, like enhancing safety and accelerating the deployment of autonomous systems. In essence, knowledge sharing encompasses a diverse range of knowledge types, like it could be declarative or procedural, structural, meta, and heuristics. And each contribute to the overall growth and development of individuals and organization by facilitating the exchange of insights, skills, and understanding. And it diverges from smart production to the smart societies. And with the advent of 5G technology, knowledge sharing has been greatly enhanced, like thanks to the improved connectivity, speed, and capabilities it offers. 5G actually technology act as a catalyst for seamless and rapid knowledge sharing across various domains, and it contributes to the overall efficiency and effectiveness of collaboration efforts. See, in this, I also want to discuss about the role of machine learning. There, in the context of autonomous systems and the robotics, there are several branches of machine learnings are crucial for enabling intelligent and adaptive systems. The integration of these with the deep enforcement learning, artificial intelligence, and the machine learnings, it contributes to the development of intelligent, adaptive, and reliable autonomous vehicles and robotic systems. And where do we stand now in terms of machine learnings? We have distributed machine learnings, and it could be used for swarm intelligence, and then reinforcement learnings with the knowledge transfer. And also we discuss about consensus algorithms. This also leads to pros and cons. Obviously, every machine learning does have some advantages and disadvantages, but the real the things is of we would like to highlight is about the cons, because in terms of deployment and then scalability issues, we always face about the transmission of data from one place to another, and then it also falls into the category of energy efficiency. And then we want to balance it up with the reduced sensors, so promoting the green communication technology. And in that case, we can extend our machine learning model to compressing the technique. So rather than using the traditional machine learning available, we can have different methodologies to compress the data. So these things are really contributing to the overall system of robotics, like in a real-time decision makings, predictive analytics, or dynamics learning and adaptations, or enhancing sensing and perception as well. With my research directions revolve around 5G enables robotics, with the primary focus on optimizing knowledge aggregations. I aim to leverage the capabilities of 5G networks to enhance the efficiency and effectiveness of information gathering in robotics, ultimately like developing or advancing their autonomy and adaptability. So creating a sustainable machine learning models to support net zero energy consumption and reducing the communication overhead. So the idea is we have a lot of sensors on the autonomous systems, or they are really using a lot of energy consumptions, and obviously with the machine learning involvement, we have to come up with the autonomy which we can leverage the knowledge aggregations to reduce the sensors, and we go towards the net zero energy consumptions. Also, that could be integrated with the 5G, because the 5G provide the platform to reduce to reduce latency and increase the multiple input, multiple output. So in that terms, we can utilize edge computing or on device inferences, and also energy aware techniques like balancing accuracy and efficiency. So this all falls into the with the machine learning's approaches, federated learnings that protects privacy and security, and these are the computationally efficient and the reduced sensors as well. I just wanted to highlight my past success. My research aims to empower traditionally dumb robots with advanced collaborative learning techniques, like leveraging AI to enhance their collective knowledge and capabilities. So in this paper we published on IEEE, we explore how the collective knowledge from the different domains of the autonomous systems can really be used with one-shot inferences to highlight and to add into the adaptability of these individual robots. So like introducing a one-shot inference is I believe a pioneering approach in AI, where model does not have to accurately predict with just a single exposure to a new data, but this innovations aims to streamline machine learnings, like minimizing the reliance on extensive training data set for efficient decision making. So in a collective manners, most of the individual robots goes through different data collections, and then they train their models. So with the collective knowledge we share with this individual dumb robots to increase the accuracy. So this methodology being utilized with the help of federated learnings. The next things we have another publications is in WCNC technical paper where I utilized another approach is temporal difference with the federated multi-task learning in connected vehicular networks. So this work introduces a novel approach at the confluence of temporal clustering and federated learning methodologies, with the specific emphasis on optimizing multitask learning paradigms with the context of connected vehicular networks. So the main idea is the use of temporal clusterings that can enhance the efficiency and effectiveness of federated learning. So in a diverse connected vehicular networks, the one collective knowledge of all the individual vehicles cannot contribute to the one global model, because in a road or in a region of a layout, the autonomous systems are everywhere. So we have to come up with where we can cluster the vehicles and aggregate knowledge and share only with the specific where the knowledge can be used for optimization. So this is where we utilize the temporal clusterings, and this is time sensitive nature, like in autonomous systems. So this research contributes to the ongoing efforts to enhance the intelligence and the adaptability of connected vehicle networks through machine learning techniques. For now, right now I am working on dynamic edge-driven knowledge aggregation for multiple robots, where we have our very own testbed 5D Scotland. And the idea is on harnessing dynamic edge computing to facilitate the efficient and adaptive techniques for multiple robotics entities. So by leveraging edge-driven strategies, we aim to enhance the collective intelligence and collaboration of multi-robotic systems. So this enables dynamic systems to operate seamlessly and resource-constrained environments. So the idea is we fusion the sensors from different robots, we train the clusters, and then we create a model and share with the robots, which has not been part of the actual data collections teams or the participants. So by doing this, we want to see how this really helps to the individual, and with the diverse environments, or like the environment changes, the robots walks into from one room to another rooms. So this he should sense the intelligence and perception of this. So this falls into a soft robotics. I already discussed about my publication. These are some of the publication I have been involved as authors and co-authors in my first year of PhD. We have 2 conferences on the 2 journals. In conclusion, I just want to highlight the framework we are doing that leverage the power of 5G to minimize communications latency, ensuring timely knowledge aggregation among autonomous entities, also advancing algorithms that plays a crucial roles to reduce the latency and the communication efficiency. So this approach is versatile. We trying to check balance the number of sensors to reduce. So with the connected vehicles, not all connected vehicles are connected with the kind of the networks. So we are benefiting connected vehicles and also the others, the dumb vehicles, which can benefit from these knowledge aggregation techniques. So the aim is to contribute to the seamless collaboration of autonomous robotic systems. Yes, that's me. Any question? Thank you.
Okay, thank you very much for your informative presentation, Mohammed. I'm checking for your questions. The question is, what measures are taken in the framework to minimize communication latency and ensure timely knowledge aggregation among autonomous entities?
So to minimize communication latency, the frameworks we have implemented is advanced algorithms that ensures knowledge aggregation among autonomous entities. Like we are trying to utilize edge computing. Obviously, not all machine learning models are efficient, so we have to bring that into from a different formats. Like we employing decentralized decision makings, like we implementing task offloadings. These approaches fosters collaborative learnings and create a responsive framework for seamless information sharing, ultimately improving the efficiency of a robotic system.
Okay, thank you so much again for your attendance in today's International Women's Day.
Cheers, thank you.
Okay, and I would like to thank all the attendees and all the speakers for their fruitful talks, and hope all you enjoyed as much as I did today. And before hand over to Dr. Nagham, I would like to ask everyone to help us to improve our webinars and fill this survey, which will take only 2 minutes. I have already put the link into the chat box. Please do provide your full name and email addresses in the survey for us to prepare your e-certificates. And again, thanks all your attendances, and I am and right now I over to you, Dr. Nagham.
Thank you very much, Kubra. So I would like to say for the second time, Happy International Women's Day. I'm the former chair of the IEEE Women in Engineering United Kingdom and Ireland, and I'm the IEEE United Kingdom and Ireland Vice Chair and the elected chair for the 2026, 2027. So here our initiatives at the IEEE Women in Engineering Affinity Group are dedicated to advancing women in technology and fostering a culture of diversity and inclusion. We collaborate to enhance early profession outreach, supporting both undergraduate and postgraduate students in engineering and computing, as well as recent graduates. I extend my heartfelt gratitude to all of you who participate in the 12 early career talks. Webinar. It is particularly fitting that it is this webinar coincides with the International Women's Day. This webinar is a unique experience that allows us to listen to 4 distinct talks on the recent technological advancements and research, focusing on harnessing the power of 5G and emerging technologies for next generation application. We are very pleased that our esteemed speakers are not only from our section, but also we have one speaker from Europe, from Turkey. So we welcome her again to our webinar. These insights have enriched our understanding of cutting-edge development in our field. For those who missed the live talks, fear not. The recorded session will be available on our ambassador's YouTube channel and the IEEE United Kingdom and Ireland chapter section website. A special shout out for the 11 sponsors for this event who unwavering support made this event possible. That is the IEEE Industrial IoT Research Group at University of West London and the IEEE United Kingdom and Ireland Society on Social Implications of Technology, the Robotics and Automation Society, Aerospace and Electronic Systems Society, Instrumentation and Measurement Society, Power and Engineering Society, Circuits and Systems Society, System Man and Cybernetics Chapter, Joint Chapter on Control and Communication Island, Computer Society, Dielectric and Electrical Installation Society. And last but not least, I would like to thank Kubra, Iman, and Yao for their invaluable contribution to organize this event. And as we move forward, we remain committed to empowering women in engineering and computing. Our next career talk will be scheduled in June, so please keep your eye on the date. Additionally, we will have also many other events coming until the end of this year, so please join us if you can. To name a few, the 3rd Women in Smart City workshop that will be at the 2024 IEEE International Mediterranean Conference on Communication and Network, Spain, July. The other one is Women in Engineering panel at the 2024 IEEE International Conference on Metrology of Extended Reality, Artificial Intelligence, and in Rural Engineering. That's London, October. So thank you, everyone. Thank you for joining us today, and we hope you benefit from our seminar. Thank you very much. Goodbye.
Thank you, guys. Thank you.
Goodbye. Thank you.
Thank you. Bye.